Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on PVTP software for retrograde condensate modeling. And in this video, we will continue the exercise or the characterization to regression step, which is a very important thing to get a good match between the model and the real fluid. Okay, but before performing, the regression, before we start considering or dealing with the regression, we should take a moment to gain an overview of how well the current equation of state reproduces the lab experiments beside the separator train calculation. And as the lab data has already been entered in the PVT sample object, direct comparisons can be made. Taking the lab experiments in turn, we will go through the process of add the appropriate calculation data object and running the calculation. Okay, so in our calculation, currently we have two calculations, the separator train calculation and phase envelope. Whereas in our sample, we have two other calculations, two other experiments, which are constant composition expansion, CCE, and constant volume depletion. Okay, this video is going to focus on the CCE. Okay, so in calculation, let's find and select this constant composition expansion object, take it from the main menu ribbon, and put it on the calculation window here. And then we double click on the constant composition expansion. Very good. And let's input the value here. We specify the temperature and pressure range over which the simulation is to be performed. So the minimum is 241, maximum also 241, number of values only 1. So it's basically only single temperature value. And then for the pressure, number of value 50. And basically, I think I need to change the unit first. Yeah. So I'm more comfortable with PSIG rather than PSI. So again, you go to Home, Units, and then let's find the pressure. Pressure, so I select PSIG. Okay, for input and output. Click on OK. Go back to CCE. Okay, so it's 241, 241, and then 1. Input mode is automatic. And then for the minimum pressure, maximum is 10,000. And for the minimum is 1,000. Number of values, 50. Okay. And for the CCE, we are only interested in the oil density and viscosity. And thus, it is not required to specify a separator train, actually. Okay, if additional data such as the GOR had been provided in the lab report, then the same separator train as used in the experiment would need to be specified. Okay, this is because the GOR is path dependent, and thus using a different separator train would result in a different GOR to be calculated. Yeah, we still maintain this flash straight to stop time. So now we press on calculate button, and then maybe you want to show this CCE. So in CCE experiment, we have liquid dropout at saturation pressure volume, and then relative volume. And lastly, we also have Z factor for the vapor or gas phase. Okay, now here on the CCE window, we go to results plot. And let's find the desired value or variables to be checked. Like in this case, as on the lab data, we have liquid dropout value. Let's find liquid dropout as well. Yeah. So the current match is like this. This green plus sign is from the lab, whereas this blue box and with a line there with a curve there is from the model, from our current equation of state model. And it can be seen that the equation of state within the pseudo properties object that we select here, so we use the fluid model here, it can be seen that the fluid model reproduces the general trend of the liquid dropout curve. However, the calculated dropout tends to be overestimated, and the initiation of the dropout is at a reduced pressure, as expected from the lower predicted saturation pressure. So we still need improvement for liquid dropout matching. All right, and then liquid dropout at saturation pressure volume here. I'm going to uncheck this. So the current matching is like this. Similar behavior can be seen for this parameter or for this variable. And we also have data for Z factor. I'm going to uncheck this, and then let's find Z factor for the vapor phase. Okay, so it's relatively good. The equation of state, the fluid model is able to reproduce the general trend of the vapor Z factor, though it is over predicting it. Okay, so the general trend is very good, but if I maximize this, we still overestimate the Z factor. And thus we need improvement for this variable. Okay, that's it. At least we have performed the CCE and we can reproduce the general trend, although we still cannot achieve very good and very satisfactory matching for the exact value. Okay, but don't worry, we still not end here. In the next video, we will do another check for the CVD, constant volume depletion experiment. Okay, until then, thank you and see you.